Okay, in this video, I just want to help us wrap up factoring and parabolas. So we have two more examples that we need to talk about that we didn't really dig in depth in class too much today about. All right, and this is the first one. So remember, the first thing that we should always do is take out our GCF. So our GCF here is 3, which is going to leave me the equation x squared minus 4. And this is an example of that difference of squares. And if you don't see it right away, you can just set this up. -4, there is no middle term, so 0. And you should get +2, -2. So when I write my factors, my factored form is going to be, let's see, y equals 3, because that's a factor, x plus 2, and x minus 2. And notice when I go to graph this, I just want you to see that this has two solutions. It's got one at, let's see, this root is going to be -2, 0, and this root is going to be +2, 0. So if I plot -2, 0, that's my first root, +2, 0. And some other things I know about this graph, I know that it has a y-intercept of -12. So I know that somewhere down here at -12, all right, I'm not going to count all the way down. We're going to have our y-intercept. And I also know that this counts, has a vertical stretch of 3. So that means I'm going to go up 3 over 1, up 9 over 1. So you can count those points as well and get your graph. So this is an example of what we call two real roots. And most of the factoring problems we've done so far have two real roots, and they're called real because we can see where they're crossing the x-axis, and two, because they're crossing the x-axis in two different places. All right, so let's look at some other options. All right, so in the second example, similar to what we did today, our GCF is not going to factor out of all of these, so we're going to have to move this 4 to the end. That's going to make us have 36 and 12. And we want two numbers that multiply that, which is going to give me 6 and 6. So when I write my factors, I'm going to have x plus 6 over 4 and x plus, again, 6 over 4. And then I can simplify those. We talked about this today too. X plus 3 over 2, x plus 3 over 2. And then we can bring the bottoms up for factoring. So my factored form is going to be y equals 2x plus 3 and 2x plus 3. Or we said today that we know we can rewrite this as 2x plus 3 squared. That's a better way to write that. All right, and then we've also done naming our roots. You know, when you have those two numbers, you have to go back to the fraction step. So our roots are going to be -3 over 2, 0. And you can list them twice, or you can just list it once, but you need to somehow denote that this is a double root, that it's happening twice. And what that's going to look like is that when we look at our graph, our parabola is going to hit at -3 over 2, which is -1.5. And it's only going to hit that one time. So a double root, you can kind of say this however you want. It either bounces or it touches and turns. Basically meaning it's not actually going to cross through the x-axis, because we know that this function already has a y-intercept of 9 up here, and that it opens up with a positive vertical stretch of 4. So when I connect my parabola, it's going to look like this. So what I want you to recognize is that when you have this double root right here, it's going to end up in this like touch and turn, where it's only going to hit the x-axis one time. Okay, so we've talked about two examples so far. What do roots look like? So we can have this two real roots where we're crossing the x-axis at two different points. They don't have to be the same point, like, you know, positive and negative. It's just that we have two different solutions, so two real roots. And then we also have this option for where it's only touching, like the touching and turning, where it's going to hit one time, and this is called the double root. And it is also real, so you could say double real root if you want to, or sometimes they call this one real root, just that it's happening twice. And then the last option you should kind of pay attention to, obviously it can either touch 2 times, 1 time, or it can be what is not going to touch the x-axis at all, and this is called no real solutions. Or the better option, that's what you called it in Algebra 1. I actually think it's better if we call this two imaginary solutions. And that's what our next lesson is going to be about, is how can we actually find those imaginary solutions. And the biggest thing that I want you to take notes on right now or pay attention to is that all of these parabolas come because we have x squared, and x squared implies always that you are always going to have two solutions. So whether that is two different solutions, like in this first case, whether it's one solution that happens twice, which is why we call it a double root, or we have two imaginary solutions, there are always two solutions anytime you have x squared. So it's very important that you know that. If you didn't learn anything else in this lesson, that's the one thing that you need to know for tomorrow and moving forward.